You would know by now, after watching the previous video, exactly how to solve any single function like x squared, e to the x, sine x. You would know how to solve any function, any single function that's given to you. Now, what we're interested in at this point is how to solve a combination of functions. How we're going to solve functions where we have a number of them put together. So the first one that we're going to be looking at, the first possible combination, is where we have a function, f of x, that is the sum of two other functions, g of x and h of x. Forgive my penmanship. And what exactly do we want to find if we have a function that is the sum of two other functions? We want to find the derivative of f of x. In other words, we want to find f prime of x. How exactly do we do that? All we do is just differentiate these. So if f of x is equal to g of x plus h of x, then f prime of x is equal to g prime of x plus h prime of x. As simple as that. Let's look at an example. So let's say f of x is equal to x squared plus 3x plus 4, right? How do we find f prime of x? We do what you've been doing all this time, solving single functions. So what's the first function here? X squared. We differentiate x squared, what do we get? 2x. We differentiate 3x, what do we get? 3. We differentiate 4, what we get? 0. So f prime of x for this function here would be equal to 2x plus 3. What about other combinations, other possible combinations of functions? Let's say that we're looking at the product of two functions. Now we're going to call these functions u and v. So y is equal to the product of u and v. How do we find y prime? Y prime would be equal to u prime times v plus v prime times u. We could also write that as u times the differential of v with respect to x plus v times the differential of u with respect to x. Any way you want to write it, prime or dv by dx, anyone you want to call it. But this is the idea behind it. We differentiate one, keep the other, and then add where we differentiate one and keep the other. So let's look at an example. So we have y is equal to x times root x. So we have two functions here, x and root x. Let's say that u is equal to x and v is equal to root x, right? Du by dx is equal to what? 1. dv by dx is equal to what? 1 over 2 root x. So what does the formula say that I should do? Well, right here, we're told that we're supposed to do what? Take u prime, which is 1, and multiply it by v, which is root x, leaving us with 1 root x. Plus what? Differentiate v, we get what? 1 over 2 root x. And we're supposed to multiply that by u, which is x. So the answer to this is that y prime, where y is equal to x root x, is equal to root x plus x over 2 root x. And we won't simplify it anymore because all we want to do is to show you the actual process of carrying out differentiation when two functions are being multiplied. So what do we do when the combination of functions that we're looking at is not a sum, not a product, but rather a quotient? Let's say that y is equal to u over v. We need to find y prime. That would be equal to v du by dx minus u dv by dx all over v squared. Right? Now, I want to point this out because this is a mistake that many people make. We're going to be differentiating both the numerator and the denominator, yes. But it is not like the product rule where it doesn't matter which one you differentiate first, because you're not going to be summing what is in the numerator. It's going to be a difference. So keep in mind that the first thing that we differentiate is the numerator. The numerator. I'm going to say it one last time. The numerator. We differentiate the numerator first. So let's look at an example. Let's say that y is equal to x squared over x plus 2. So y prime, well, before we even go to y prime, let me tell you what is u and what is v. Let me change the color. So u would be the numerator x squared. V would be the denominator x plus 2. So y prime would be, so let's differentiate the numerator. Differentiate x squared, what we get? We get 2x. And then we're multiplying that by v, which is x plus 2. Now we're going to be subtracting the product of u, which is x squared, and the differential of v. The differential of v is what? Differentiate x plus 2, we get what? 1. Differentiate that now by v squared. What's v squared? X plus 2 all squared. So what does that leave us with? That leaves us now with x squared plus 4x all over x plus 2 all squared. And that is what? This is dy by dx when y is equal to x squared over x plus 2. And again, it is the same intuition. This expression here is saying to you, plug any x value in me, and I'm going to tell you what the instantaneous rate of change of y with respect to x is at this point.